I'm Dustin McIntyre. I work at the National Energy Technology Laboratory in Morgantown, West Virginia. I'll be presenting the Miniature Subsurface Laser Induced Breakdown Spectroscopy, or LIBS system. NETL's miniature probe and LIBS system can potentially help petroleum operators, regulators, municipalities, and landowners who are interested in determining whether or not the subsurface activities they're involved in may be causing significant changes in the environment. This is done by quickly measuring trace elements in the subsurface, liquids or solids, while on site, unlike the current systems that require you to grab a sample, take it away, process it, and then analyze it. The miniature LIBS probe is essentially taking the laboratory to the subsurface, not just to the field, but to the subsurface underground. We have worked on benchtops LIBS systems, and we have used additive manufacturing for our current productization efforts. We are seeking partners to reduce the system size and cost. And we're also interested in adding Raman spectroscopy to the system so we can have an idea of the molecular components in addition to the elemental components. Once again, I'm Dustin McIntyre. I'm the research lead. I'm studying miniaturized laser design and system integration. I work with Dan Hartzler, who is an expert in atomic and Raman spectroscopy, as well as optical design and fabrication. I also work with Chet Batt, who is an expert in spectroscopy and plasma interactions and novel optical measurements. Customer insight that we have gained from the last several years of work essentially states that people are interested in taking measurements more rapidly while reducing costs and not taking up valuable real estate in the subsurface, and also producing precise measurements of potential tracers. The problem definition that we have is that there's a large time delay between when you take a sample and when you can get that data back to make decisions. Sometimes the reaction measures in the subsurface are on a different scale than what the return time for the data is. So they want things to be more timely. They want to reduce costs because there's lots of moving parts in this system, and to reduce that would help reduce costs. And they're interested in high resolution, high quality data that can be produced in the lab, but if you can produce in the subsurface, that would be a positive. The LIBS probe and system can be placed on site in a measurement area, perform elemental analysis multiple times a second, no sample preparation. We believe it can be done at a lower cost and in hostile environments such as high acidity. Essentially, we're taking the laboratory to the subsurface with this probe and system. We can perform trace element concentrations from the parts per billion up to the percent level. Continuous measurements can be done around the clock, multiple times a second if necessary. No sample collection or preparation, and we believe the probe costs can be way less than $10,000 eventually with more engineering development, and the mobile base station can be much less than $80,000. An example of a LIBS system is what is currently on Mars, ChemCam, which is on the Curiosity rover. It's almost 10 years old. And the SuperCam that is on the Perseverance rover has both LIBS and Raman capabilities. Current options are that you can travel to the sampling point, collect the sample, take the sample to the lab, prepare it, and wait. Or you can deploy electrical or optical probes into the subsurface, but you only get bulk information about the water contents, such as turbidity, pH, electroresistivity. You don't know exactly what components are causing which one of those characteristics to happen. The benefits of our system, it's all optical, so there's no chance of any electrical interference, and it can withstand harsher environments than some of the electrical components. We have been working on miniaturizing the component count and the processes downhole to make it as simple as possible. And we think we can have a lower unit cost eventually for the deployable component. And on the surface, we will have our more expensive, delicate components that we will not be able to fit downhole, but can provide us the high resolution measurements. In the subsurface, all the control and data will go through a single optical fiber. All optical rugged components will be in the subsurface that can be in a detachable form and left in place in case you want to take the more expensive and delicate components from site to site, or we do have a intellectual property on connecting them all into an optical network. The current status of the technology: we have a miniature prototype that's been tested in the lab for the last couple of years. We've validated all the laser optical parameters. We have optimized the beam shape to improve performance. We have significantly increased the efficiency of the overall device by the modifications that we've made. And we recently tested this in the subsurface this spring. Potential markets are always oil and gas, mining, aerospace, rare earth element separation, which is one that we've been looking at for the last couple of years. Environmental analysis can be used as a feedback sensor for chemical processes, forensics, medical device, alternative energy manufacturing. The initial market that we're looking at is a subsurface sensing for oil and gas applications. We think that that'll be the easiest entry point to gather information and to establish a foothold and show the people that this thing can do exactly what we say it can do. And then we can add options and we can go into other industries and fields of operation from there. We are continuously trying to engage partners to reduce the size and cost. We are continuously trying to secure funding to add Raman spectroscopy and other characteristics to this measurement device. We are seeking additional intellectual property protection. And when we are allowed to travel, we are happy to spread the awareness of this system and its capabilities. Once again, my name is Dustin McIntyre, and if you have any questions, let us know. We did win an R&D 100 award a couple of years ago for this setup. Thank you for your time and attention.